Hello everyone. Before we start, you have to understand that functions and the idea of functions is used in almost every branch of mathematics, such as algebra, geometry, calculus, and also statistics and many other branches. Welcome back to Math Top Grades, and today we will have function and function notation. The idea of function is very simple, just input and output, okay? Get ready and let's stop wasting time. Get your notebook ready and your pen. Let's go. Over here, you have to be familiar with the two common forms of notation used for functions. The first form is f of x here equals whatever the function is, okay? Or it will be f when x, then this function will be given to you. However, in this course, this form will be the form which you are going to use. You will not use that, but you still have to know it. Maybe you are going to face it in one book or two. Yeah. Now, the idea about functions is based on input and output. Your input here is x. Your output will be f of x, okay? And this can be easily explained by a flow chart or flow diagram. Like what? Here, if you try to understand what's happening, 3 is multiplied by x, then you subtract 1. Okay, so at the beginning you have x. The first operation happened here for x is what? Is multiplied by 3. So simply you will multiply by 3. Okay, what will you have then? 3x. After that, what will happen? You'll subtract 1. So this is here minus 1. Okay, and after that, it will be 3x minus 1. With variables only, maybe you can't understand it properly. Here, if I want to find, for example, f of 2. If you notice here what happened, this x here is replaced with 2. All you have to do now is just replacing x with 2 and do the same operations you have, which means here I'm going, instead of this x here, I'm going to write 2, okay? 2 multiply 3 is what? 6, then minus 1, which is going to be 5, okay? Of course, you don't have to do this, but I'm just explaining the idea of functions, which is input. Here your input was 2, and here your output is 5. Okay, now let's have examples, okay, on many forms of functions, and definitely you are going to face it later in the exam. Let's take a look at the first example with us today. Here I have 3 functions. I have f of x over here, g of x, and h of x. Of course, we are naming them with 3 different letters because they are 3 different functions. Okay. Right now, let's take a look at the first question. Find f of 2. F of 2 means you will have to go to function f over here and substitute x with 2. In other words, it's going to be 3 and replacing x with 2 minus 5. So 3 multiplied 2 is 6 minus 5 equals 1. So your answer here is 1. Okay. Find g of negative 2. G of negative 2. So again, you go to which function? You have to go to function g, the second function which we have today. And substitute x with negative 2. Let's write that together. 3, open brackets here, negative 2 instead of x, plus 4, okay? All of that over what? All of that over 5, okay? And here, when you do the calculations, the answer is going to be 6 over 5. It's better to write it always as a fraction. If you want to write this as a decimal, it's fine. But if you have a denominator of 7 or 3, it will be very hard to write it as a decimal. So it's better always to write your answer as a fraction in simplest form. Okay? Okay. I need to find h of -4, so I go to function h, substitute x here with -4, and pay attention to that, please. I'm going to write 2 here, and instead of x, I'm going to write -4. Because x is negative and it's squared here, as you can see, so it should be in brackets -4 all squared. Don't forget to write it in that way, and the squared is outside the brackets. Okay, then plus what? Plus 3. Okay, here this is going to be 2 multiplied 16 is 32. 32 plus 3 is 35. Okay, now pay attention to question D, please. Find x. So here he's not asking you to find the value of f of 2 or f of 3 or whatever. No, he's asking you to get the value of x when f of x equals 1. Here again, it's based on substitution. Put this in your brain, please. When it comes to functions, the main idea here is substitutions. Okay, so when you substitute f of x with its value, here f of x equal what? F of x, Mr. equals 3x minus 5. So I'm going to substitute here this, replace it with 3x minus 5, and equals 1 as given to us. And now you have to solve this equation here to get the value of x. So as usual, plus 5 plus 5. You are making the opposite operation if you remember how to solve equations here. So 3x equals 6, and divide by 3 in both sides. So x equals 2, and this will be your answer for that. Now let's take a look at this example here. In this example, we are going to talk about something called composite functions, as you can see here. Okay, composite functions means a function and another function are combined together to form one function. Such as what? If you take a look here, I have function f. Okay, he gave me this function f here. Okay, I have function g, okay, and also it is given to me. The question is asking, find fg of 2. So fg of 2, this is a composite function where g of 2 is performed first. Always, 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 the function on the right must be performed first. Yeah, now you will get g of 2 alone. Okay, to get g of 2, you'll go to function g, substitute x with 2. So it's going to be 7, and here 2, power of 2, minus 25. Okay, 7 multiplied 4 is 28. 28 minus 25 is what? Is 3. So this is g of 2. As I told you, this is the function which should be performed first. Okay, what is next? What is next is to replace g of 2 with the value we got here. So we are going to write f, and instead of writing g of 2, you write f of 3. And as usual, f of 3 means you will have to go to function f over here and substitute all x's you have with 3. You will substitute all x's with the same number. Okay, so 2, open bracket, 3, power of 3. Okay, plus 4, open brackets, 3, power of 2, plus 7, multiply 3, plus 1. After that, you can just do the calculations. 2 multiply 27 is 54, plus 4 multiply 9 is 36, plus 21 and 1, 22. Okay, so here is going to be 1890 plus 22. It's going to be 112, and this is
how to deal with composite functions. Remember, always the function on the right must be performed first. Is it always like this? No. The question will always bring you here g of a number or a number and get the answer? No. Come here about composite functions also, which is f of x here equal 3x plus 1 and g of x equal 2x squared minus 1. Okay. Here, unlike the first question, we had a number. He gave me x. He didn't ask me to substitute with anything. In question A here, he is asking me to get f of g of x. Always, number one, you start with the function on the right. Okay, so here is going to be g of x. G of x equals what? Equal to x squared minus 1. Here, f, and instead of g of x, as we agreed, I'm going to write its value, which is 2x squared minus 1. Okay? Now, what are we going to do? We will go to function f, which is here. Replace x with the value you just wrote over here. How can we do that? So simply 3 is here. And instead of x, I'm going to write 2x squared minus 1. And please don't forget this one outside here. So plus 1. Now, the next logical step is to expand. So it's going to be 6x squared minus 3 plus 1. So 6x squared minus 2. This is your final answer here. Okay? Let's go to question B. Here, g f of x, which is the opposite of that. G of f of x, I'm always starting with the function on the right over here, f of x. So it's going to be g, and instead of f of x, I'm going to write its value, which is 3x plus 1. Okay, then what? Then again, I'm going to function g, replacing x's in this function with what? With the value I just wrote. So g, خلاص, instead of writing g, I'm substituting now. So it's going to be 2. And instead of x, I'm going to write 3x plus 1 all squared. And this is minus 1. This is minus 1. Now again, it's expand. But don't you ever multiply this here. You can't do that because you have this square. So the first step is to expand that square. Square means the same brackets multiplied by itself. So 3x plus 1 multiply 3x plus 1. Okay? Which is going to be, after distribution and expansion, is going to be 9x squared plus 6x plus 1. Let's write it down here. So 9x squared plus 6x plus 1 minus 1. Right now, because you don't have square over here, you can immediately, multiply this here, and also there. So it's going to be 18x squared plus 12x plus 2 minus 1. Okay, and now let's find it in simplest form. 2 minus 1 is 1, so 18x squared plus 12 plus 1, 12x, I'm sorry, plus 1. Okay, let me write it again. It's going to be 18x squared plus 12x plus 1, and this is the final answer in simplest form.
Let's take a look here at example 2. In example 2, draw flow diagrams for the functions And here the first function we have is f of x 3x plus 4 all squared. So step by step, according to the order of operations, what is the first thing happened to this x here? It's multiplied by 3. So I'm going to write x, and what happened as we said? We said multiply by 3. You write it like that, okay? And when you multiply it by 3, multiply x is going to be 3x. Okay, then what? What happened after that? Add 4. So simply, you will make another arrow, add 4, okay? 3x plus 4, x plus 4. And then what happened if the square, so simply you will make an arrow, then you write square, and then it's going to be 3x plus 4 all squared, and that's it. Okay, this is how to draw the flow diagrams for this function. Let's take a look at another example. This part is so easy, but let's take a look at another example in case you didn't understand that. Okay, I have here g of x equals 4 minus 3x. Okay, x is here. This is my input, or this is my input. What happened to x here? It's multiplied by what? Many students actually said multiplied by 3, which is wrong. It's actually multiplied by negative 3. And because here, can you see this negative? This is very important. Don't you ever ignore it. So here you write multiply. Don't write x3 because for many students it's confusing. Mister, is it multiplication or is it x? That's why I prefer, and you should do that also, when you multiply it in letters here. Multiply by negative 3 as we agreed. So when you do that, it will be negative 3x. Okay. After that, what happened? Plus 4. Okay. Or divide by 5. Many students will say, okay, mister, according to order of operations, I'm going to divide by 5 first. No. Why? Because here you have to deal with this numerator first as one quantity, not just divide by 5 first, then add the 4. Okay? So here you are going to add 4. Because 4 here is positive. Okay? 4 here is positive. So simply you are adding 4 to negative 3x. So 4, you can write it negative 3x plus 4, or you can write it 4 minus 3x. Actually, both are equivalent to each other. It doesn't really matter. Then what? Then you divide by 5. Okay? And when you divide by 5 here, okay, let me just get this here. Okay, when you divide by 5, what will you have? It will be the expression you have, the function you have, which is 4 minus 3x over 5. And this is your final answer. This is how to draw the flow diagram for this function.
Okay, right now let's talk about inverse function, okay? In a simple way, inverse function means to do the opposite of what your function does. And you will do everything backwards. And to do that, to find the inverse function, we have two ways. What are these two ways? The first way is to use the flow chart or the flow diagram, okay, and make it backwards, okay. Second way is to make y subject, and we are going to explain both ways right now. First, let's draw the flow diagram of this. Here, what is your input? Okay, because again, the inverse function is doing everything backwards, so your output is going to be your input. But first, let's find here the flow diagram first. So I have here x. My input here is x as usual. Okay. x. What's happening here to this x? It's multiplied by 3, so it's multiplied by 3. It's going to be 3x. Okay. After that, what's happening here? Plus what? Plus 1. So you write here, simply add 1. It's going to be 3x plus 1. Put in your mind that here, this is your output and this is your input. Okay. This is the normal function. To find the inverse of the function, so here instead of your output, here it must be your input. What is your input normally is x. Okay. Then when you go backwards, okay, you will go here like this, and you will you'll get the opposite operation. Yani here when we go backwards, we had here add 1. What is the opposite of add 1? Subtract 1. So you write here subtract 1. Okay, and it's going to be x minus 1. Let's do the same thing here when we go backwards. Okay, x minus 1, here it's multiplied by 3. What is the opposite of multiply by 3? It's what? Divide by 3. So in this case, it's going to be x minus 1 over 3. Simply, you can write f inverse, the inverse function of x, equals the function you got here, which is x minus 1 over 3. And this is the first way to solve this. Let's take a look at another example to make things clear in case you didn't catch it. Here, again, find f inverse of this function. Okay, my input is x. What is happening here? What's happening here is multiply by 5. Okay, white on white doesn't, it's not clear, so you write multiply by 5. It's going to be 5x. After that, what is the next step? Subtract 2. Okay, subtract 2 to be 5x minus 2. After that, what is happening? Divide by what? Divide by 3. It's going to be 5x minus 2 over 3. As I explained before, this is your output, okay? And here, this output is going to be changed to be your input, okay? And our input usually is x. We will go backwards, okay? And everything here is going to be opposite. It's going to be reversed. What's happening here? This is divided by 3. So it's going to be multiply by 3. Multiply by 3. It's going to be 3x. Then, what is the next step here? Subtract by 2. So here it will be, what is the opposite of subtraction? The opposite is addition. So add 2. It's going to be 3x plus 2. After that, what will you do? Go opposite again. Multiply by 5. What is the opposite of multiply by 5? It's divide by 5. So divide by 5 is going to be 3x plus 2 over 5. And in this case, the inverse of your function is going to be 3x plus 2 over 5. This is how to find the inverse of the function using the flow diagram. Now let's take a look at the second way, which is about finding it using making y a subject. Okay, so let's take a look here. Let's take the same exact question here, okay, in a new page, and let's do it together. Find the inverse of the function. I have steps, okay, I have steps. If you follow these steps, so you will be able to do it easily. The first step is change f of x with y. With what? With y. You remove this f of x here and write y. Okay, let's do that. So 3x plus 1 equals y. This is your first step. But what is the second step? The second step is to make x subject. Make x subject. Making x subject means to isolate x. Means what? To isolate x. So how can you isolate x? Like solving for x by doing opposite operations here. So instead of plus 1, it's minus 1 here, minus 1 there. So it's going to be 3x equals y minus 1. Divide by 3, divide by 3. So x equals y minus 1 over 3. This is your second step. Now x is isolated, so x is a subject. But what is the third step? The third step here is to change x with f, the inverse function here. And you change y with x. What do you mean, Mr.? I mean here, this x over here, you replace it with f inverse, the inverse function. Here, you write f inverse of x. And replace y with x. So replace this y with x. It's going to be x minus 1 over 3. And this is your final answer over here. Okay, I hope this part is okay for you. And if you have any problems, just pause the video and try to do it yourself once and twice, and with more practice you will find that it's very easy for you. Now let's speak about domain and range. What's the meaning of domain and what is the meaning of range? In a simple way, domain is all possible values of x. Yani what you can substitute x with. You can put x with 1, x with 2, x with 3. So this is your domain. The inputs, all possible inputs. Here, if we speak about the range, so that means all possible outputs when you put these inputs. Let's make it simple for you. For example, in this function, I have 4x minus 1. And 4x minus 1, I will put some numbers, any random numbers. For now, 1, 2, 3, for example, 4. Any numbers. Substitute in your function here to get the value of y. Substitute 4 with 1, with 2, 3, and 4. When you substitute 4 with 1, you will have here 4 times 1 is 4 minus 1, 3. Okay, 4 multiplied 2 is 8 minus 1 is 7. Okay, substitute with 3, so 4 multiplied 3 is 12 minus 1, 11. And do the same thing here is going to be 15. This is just the table of values. And if you have this table of values and I'm asking you to write the domain and the range, you will tell me, Mr. The domain is 1, 2, 3, and 4. And you will tell me that the range is 3, 7, 11, and 15. Okay? What about the mapping diagram? In the mapping diagram, I'm going to represent the same thing I did in the table here, but in a mapping way. Here, I have x's, and here I have all possible values of y. Okay? For example, as the numbers we used, the 1, 2, 3, and 4, and the values of y which we got 3, 7, 11, and 15. So let me write, for example, 3, 4, 7, 11, and 15. Okay? 1 here is has an image of 3, as you can see. So I will have to draw an arrow from 1 to 3. Okay. Same thing, 2 to 7. Okay, 2 to 7. 3 to 11 here, and 4 to 50. If I'm asking you what is the domain, you will tell me the same values, 1, 2, 3, 4. If I'm asking you what the range is, many students will mention the 4, which is completely wrong. I don't have any arrow going to the 4, so you can't choose it within your range. So your range here will be the same, 3, 7, 11, and 15. Okay, it will be the same exact answer. So because we don't have any arrow heading to 4, 4 is out of our range. Okay, let's take a look at this example here. I have f of x equals 3x minus 5. Okay, that's great. The domain of f of x is this. He gave me the domain already, and he's asking you to find the range. So this question is quite simple. Okay, what should we do here is simply substitute with all of these numbers here. So 3 multiply negative 3 minus 5. This is going to be negative 14. Okay, 3 multiply 0 minus 5 equals negative 5. What am I doing here right now is substituting x here with its value. Okay, and then substituting here with 2. So 3 multiply 2 minus 5. This is equals 1. Now simply your range equals negative 14, negative 5, and 1. This is the range of this question over here. In the next part, we are going to have a function, and he will ask you to get the domain and the range of that function. So please pay attention. It's very important and easy also. Here, when you have to get the domain and the range of any function, you have to remember two important things. The first one is you cannot divide by 0. For example, if you have here 1 over x, and I'm asking you to get the domain of this, that means you can put x with any number except 0. You can put x here with any number except what? 0. For example, if your question was 1 over, or make it مثلا 3x over x minus 5. Okay? Here, in this function here, you can put x with any number except what? Except the value which will make your denominator 0. So what is the value which will make your denominator 0? Here, x minus 5 equals 0. So x equal 5. That means you can put the domain here. You can put x with any value other than 5, so x cannot equal 5. And we'll take this in the second example. Also, you have to know that the square root of a negative number is not a real number. In other words, you can't get square root of negative quantity. This is not acceptable. This is not a real number. Which means what? Which means whatever below the root must be greater than or equal 0. This is what that means. So again, what that means whatever below the root here must be greater than or equal what? 0. And we will use it to get the value of x. Let's do that together here. Determine the domain and the range of this function. This function here is a root function, okay, square root. So 3x minus 1, this is whatever below the root, must be greater than or equal 0. Now we are going to solve this inequality to get the domain. To get what again? To get the domain. Let's solve it together. So 3x here greater than or equals positive 1. Divide by 3, divide by 3. So x greater than or equals 1 over 3. How can I write the answer here? You can simply, you write here the domain, okay, or just D equals, and pay attention to this form, please, x, where x must be greater than or equal third. This is how to write the domain in this form. Because here, okay, Mr. X is greater than 1 over 3. So X can be equal 1, 2, 3, 4. X can equal infinite number of numbers. Okay, so you are writing it in this form to tell him generally that X must be greater than or equal 1 over 3. Okay, so Mr. What about the range? The range of this square root must be greater than or equal 0. And remember, when you get the range, that means you are getting y. You are getting what? Y. You are getting the output, as we said before. So you are saying that the range is y, where y must be greater than or equal 0. Okay, and this is it's always like that here. This is the range of the square root. Okay, fine. Let's take a look at another example here, and important, and pay attention to that. Not because it is hard, no, it's because it needs a little bit concentration. Okay, just focus with me. Here, determine the domain and the range of this function here. Okay, how can we get the domain? This is rational. This is called rational function, or irrational, or it's called a fractional function, whatever they call it. Okay, what we care about here is this denominator. As I mentioned earlier, this denominator cannot equal 0. This denominator cannot what? Cannot equal 0. So to get the domain, I have to get the value of x, which will make it 0. And I'm going to write 2x plus 5 equals 0. Then I'm going to solve it here. 2x equals negative 5 over 2 over 2. So x equals negative 5 over 2. That means to get the domain equals x, where x cannot equals negative 5 over 2. Now you are telling me that you can put x here with any value other than negative 5 over 2. Okay, but what about the range? Pay attention, please. Here, in this style of questions, to get the range, you understand that the range is the values of y. Okay. First step is to make x subject. Again, what is the first step here? The first step is to make x what? Subject. Okay. Let's write here our function for x. Step by step, no need to rush, please. It's better if you have a pen and you write the steps with me. Try to figure it out yourself. This is much better than watching the video only. So 2x plus 5 equals what? Equals y. To make x subject here, I'm going to make cross multiplication. Okay. So to make cross multiplication here, what will we have? We will have 4x equals 4x, because here it's like over 1, and when you multiply 4x by 1, it's just 4x, equals y multiply by what? Here y multiply by 2x plus 5. Okay, let's expand this bracket. So 4x equals 2xy plus 5y. To make x subject, you have to make sure that all x is in one side. So simply, I'm going to move this to the other side with a different sign. So 4x minus 2xy equals positive 5y. Pay attention to this, please, because you will face this a lot when you rearrange formula or to make any variable as a subject. If you have the variable you want more than once, the idea here is simple, which is to take this variable as a common factor. So here is going to be x as a common factor. I will have here 4 minus 2y equals 5y. And to get x as a subject, remember that x is multiplied by that. So to get x as a subject, you will divide by this bracket. And divide by 4 minus 2y in both sides. And in this case, x equals 5y over 4 minus 2y. What is the point of making x subject? The point of making x subject is I need to know the possible values of y. As you can see here in this final step, we have y in our denominator. And you know, we cannot divide by 0. You cannot divide by 0. So we have to get the value of y, which will make this denominator 0. So 4 minus 2y equals 0. So 4 equals 2y, divide by 2, divide by 2. That's here y equals 2. So this value will never appear in our range. That's why you can write here that the range r equals y when y cannot equals 2. Okay, here, of course, here, this is a colon here. What should we do here? The range is any value which cannot equal 2. This is all other values are possible. You can get these values, and this is how we got the range here, and this is how we got the domain here of this fractional function. At the end, remember that without practice, all of this is completely useless. That's why in the next video, I will show you exam-style questions from the past papers. So get tuned, and please, if you like the video, like and subscribe. Thank you very much for watching, and have a nice day.